Hey guys, Mr. Palmer here with another AP problem. This one's on chemical equilibrium. If you want to try this one on your own, see how you can work it out, and then you can sit and go through my description of it. So I'll take this one piece at a time. This one's involving the decomposition of nitrogen or dinitrogen tetroxide into nitrogen dioxide. You're given a balanced chemical equation showing the equilibrium as well as the enthalpy change of the forward reaction. You're asked to write the equilibrium expression, calculate some concentrations, and then initial concentrations, and then find the equilibrium concentration. So we're going to go through one step at a time. First, part A, writing the equilibrium expression for your reaction. So we're just taking the products, we're putting them over the reactants, and we're raising them to the power of their coefficient. Since these are both gases, they're not solids or liquids, both are going to appear in the equilibrium expression. So I think in an open-ended problem, that'd probably be 1 point. Second part, part B, you're asked to calculate the initial concentration of the N2O4. So if we're going to find an initial concentration, we're given a mass in grams and we're given a volume in liters. We need to take the mass in grams, N2O4. We are going to calculate the molar mass. 92.02 is what you should come out with for every 1 mole of N2O4. That's going to give you 0.576 moles of the N2O4. We need a molarity. Molarity is moles per liter. So we have 0.576 moles. And we are told that it is a 5.0 liter container, which is going to leave us with, to two significant figures, 1.2 molar solution. And I would say in in an AP free response question, that'd probably be a point value, just 1 point for that part. Part C is the really difficult part. This is where you're asked to calculate the equilibrium concentration of the N2O4. So this is going to be an ice problem. So we're going to have to set this up for ice. We're going to write out N2O4 is in equilibrium with 2NO2. I'm going to write the ice part right here. Let me switch colors. And so we initially have what we just calculated in the last one. If I go back, we said that the initial concentration was 0.12 molar. So I'm going to write 0.12. And for the NO2, that was initially 0. There wasn't any of it in the container. So let's talk about what's going to happen. If there's all reactant and no product, we are going to go to equilibrium, shifting to the right, which means the N2O4 is going to go down. It's going to decrease by some quantity, which we can call X, which means that the NO2 is going to increase, and that's going to increase by 2X. So finally, at equilibrium, the last part of our ice, that would leave us with 0.12 minus X for the concentration of the N2O4 and 2X for the concentration of the NO2. And we can then substitute it back into our equilibrium expression. So we had the Kc is equal to the NO2 concentration squared over the N2O4 concentration. And so if we take our equilibrium values and substitute each of these into the equilibrium expression, as well as the value of the Kc, we can solve. 0.029 is our Kc, 2X is the concentration of the NO2 squared over the concentration of the N2O4. Now at this point, this is going to give us a quadratic equation. So if I multiply through our values, we're going to get 0.0035 minus 0.029x equals 4x squared. Now if we bring everything over and set it equal to 0, I'm going to get 4x squared plus 0.029x minus 0.0035. And so we're left with our values for our quadratic, our A, B, and C values that we can put into the quadratic equation. And if we substitute substitute those into the quadratic equation, right? Our x is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. We're going to get two different values for this. So the first value comes out to be negative 0.033, and the second value is 0.026. And you should realize that one of these is going to be incorrect, and that is the negative value cannot possibly work. We can't have a negative concentration for the NO2. Now, that is not our final answer to this question, because it asks us what is the concentration of the N2O4. So the original concentration, we already said, was 0.12. It's going to decrease by some quantity x, which we calculated as 0.026, which leaves us with a concentration of the N2O4 being 0.094 molar. So that is the answer to this one. I'd say that's about a 3-point question. I'd say one would be setting up the ice correctly with the stoichiometric ratio. You'd probably get a second point for correctly substituting into the equilibrium expression, and then a final and third point for calculating the concentration of the N2O4. I'm going to pause there, stop it, and I'm going to come back with part 2, solving for the rest of it.